Today we're going to firstly talk about an example of a shared memory process, or what are the main functions that we can create. Okay. Then we're going to talk a little bit about what are sockets and how you can, and what is the mechanism to exchange messages. Okay, so the other technology that we don't need to write into the same memory. And then we're going to go to our practical exercise. All right. So an example of a shared memory system is the POSIX shared memory. Okay. So this system has an API, okay, that allows us to use a few functions that can create a shared memory and also allow processes to write into it. Okay, so you can see that here, for example, the process to create the shared memory is called SHM open, where we can add the name of the process, and if a process, for example, haven't been created yet, we created it. If it's already been created, we just assign it to this variable right here. Okay. So we can also add a size to our shared memory. So obviously, when we have shared memory, we need to define how big it is. If the shared memory it's infinitely big, this means that a process potentially can write too many things into it, flooding our operating system. Okay, so this is a function with which you can specify, for example, a shared memory and how much bytes you want to allocate to it. All right, and finally, here there is an example of a function that can actually write to a shared memory. So we keep the thing simple again. We just specify, we just specify the shared memory, and then we specify the message which we want to write to it. Okay. All right. So this is scratching the surface on what we're going to be doing today. Of course, we're going to use Python for those examples, and there we're going to also use a similar library, okay, which is called multiprocesses. Okay. Actually, also next time we're going to talk about threads, and you're going to actually see the difference between threads and multiprocesses. So this will also be something very interesting. In fact, I'm also considering doing another practical exercise. I will see when, where I will show you how you can create and manage threads automatically, right? There are a few ways. Okay. So now this is the functions that we're using when we want to share memory. But when we have two processes that don't share the same memory, they obviously need to exchange messages, right? So the question is, what is the way and what is the easiest approach for two processes to share some messages? So normally, and this is applied into every operating system, normally in data communications, you have a few layers, right? On the top you have the application layer where your application runs, then you have transport layer, network layer, data link layer, physical layer, right? So what our goal is always is to isolate everything under the transport layer, so the programmers actually don't deal with it, and they can focus only on the application layer or what their actual application is going to look like. The rest we want to be handled by the operating system. Okay? So in order for us to do that, we can create something that is called socket. Who has heard about sockets? You heard about socket, no?
I think we talked about it a little bit in the last class.
Yes, true. So, exactly. Now, socket is a combination of IP address and port. So, the IP address comes from the network layer. Okay, this is the specific identifier of the network layer, and the port number is the unique identifier of the transport layer. Okay, so with the network layer, we identify the location of where we want to send a message, and with the port number, we identify the process on this network to which we want to communicate with. Okay, so since we can access all the rest of the layers with those two entry points, IP address and port number, we can create a variable called socket, and socket is simply a combination of IP address and a port number. Okay, and it is called socket because that way you can plug together two processes or two applications to communicate. So what the sender needs is the IP address and the port number of the receiver, and then the sender can send messages to the receiver, and the other way around. Okay, now there are also port numbers that are well known. So well known, does anybody knows what is well known port number? Yeah, so what is well known? So they are well known and not well known port numbers.
Well known port number 8282.
8182?
8282. For example.
Oh, okay, 81 and 82. Yes, okay, now I got it. And 81 is of which protocol? Do you know?
No, sir. I didn't say that.
Okay.
I said 8080.
8080.
Yeah.
Okay.
Like it is used for Jenkins server.
Okay, yes. Okay, yes, this is a well-known port number. True, true. So if 8080, like you said, right, is it's always the port number of the Jenkins server, this means this is well known. So every time when you create a Jenkins server, it will always be with port 8080, right? Also, if somebody wants to contact a Jenkins server, they will only need the IP address because the port number is well known. Everybody knows it. So maybe not everybody in the room knows about Jenkins, so I will give you one more simple example. Let's say if you want to send, let's say, okay, when we use the HTTP protocol, when we want to access a website, okay, so the HTTP protocol, which we use to access a web page, always uses port number 81, okay? So if you want to access a website, you just need to write the name of the website, which is linked to an IP address. You only need to add the IP address of the website, and then it is assumed that the port number is 81 because it is well known. When we have well-known ports, we can use some basic services for all computers to communicate together. The same is if you want to send an email, if you want to send and receive files, and so on. The custom port numbers are used for custom applications. If I create a custom application, let's say I create TikTok, right? So I want the users with that use TikTok to communicate. So then I will have a different or specific message in the application layer of TikTok, and the users that send and receive those messages will use a different type of protocol. Okay. Also, in your computer, if you want to run some custom application and you run it multiple times, every time you can use different port number, right? So the well-known ports, they are always busy for the particular services. The not well-known, they are assigned, and after the communication finishes, then they are deleted. Okay? Yes, specific. So those are free ports for any application. If an application wants to take some port, those are available for somebody to take them. Exactly. Yes. Yes. All right. So you can see that here we have two applications that are communicating, okay, or actually two sockets, right? So let's say this is your IP address and you want to communicate with a web server, right? So this is your IP address and you open a port number on your site. So obviously the port number on your site is going to be a custom port number, right? Because you open an application. Then when you want to reach the web server, you're going to write the IP address and you're going to use a specific port number that is well known in order to access a web server. So you're going to use port 80. And you need to only provide the IP address because the port 80 is going to be already assumed by your browser, for example. Okay, so this is just a simple example of how sockets, for example, are implemented in Java. Okay, just so you can see how it looks when you actually want to call the socket. So obviously Java is object. Yes.
Sorry?
Yeah. Good question. So normally when you come in. So normally the important port is the one of the application that you want to communicate with, right? Let's say if there are two web applications communicating with each other, okay, they might be communicating both on port 80. But if I'm a user, right, and I want to reach a web page and I want to send a request to this web page, okay, I need to know the IP address and I need to know their port number, and I do the request, right? So I send the message to them. Once I send the message, there I can include my IP address and my port number. So my port number can be custom. So I send a request to them, let's say to google.com at port 80, and then Google receives my information, sends me a response at my port that I open at my device. Okay, so pretty much this is how it works. So you don't need to have, let's say, port 80 open on one side and port 80 open on the other side. It's just to access the web service. Yes.
For users, let's take the example.
Yes, for me it's gonna be a random port.
And once you use it, the system releases it back in your port.
Exactly. It is random, but also if you have some preferences, you can just use any available free port on your system, right? So for example, if you write a software on Django or on Flask, which are Python frameworks, there you can simply specify which port you want to use on your site, right? So I can specify 5000, 5001, whatever I want. Okay, so it's not just picked randomly, which is the default option, but also you can pick it yourself. Okay, yes. So this is an example on Java how you can create sockets, and obviously here you can use so obviously since Java is object-oriented programming language, you have this class that is called server socket, with which you can create a server socket and then use it, right? So you can see that there are also different functions. So how it works usually is you create a server socket, okay, and after that this server socket object has different functions. For example, to accept a client, okay, to write to the socket, to receive information to the socket, and so on. So normally to the sockets you can write from them and read from them, just like if you connect your keyboard or monitor to your computer, right? So the keyboard writes into your system and the monitor reads from the system wherever picture there is there. So you can do the same things into sockets. You write into a socket and then you get information from a socket as well. Okay, so another very popular way of communicating is called pipe. Okay, so pipe is a little bit different than client-server communication, because with pipes you can imagine it as establishing a connection between sources and destination, like a lifeline, instead of sending messages, right? So you can establish a pipe that connects two processes, and then on one end of the pipe you are writing something, and then on the other end of the pipe you can read something, okay? A very popular way for creating pipes between two devices, let's say, is the SSH protocol. Have you heard of SSH? Okay. So, oh, you've heard from data communications, yeah. Yeah. Sorry? Yes. So you always use SSH exactly to create a pipe, or there is called a tunnel between two processors or two devices, and this tunnel is secured, right? You write username, password, so it has authentication services. SSH ensures that your message doesn't get altered uh, along the way, and a very good practice is normally to use an SSH to create an SSH tunnel between two devices, and then on the top of that you're using the rest of the protocols like file transfer, HTTP, and so on. That way, even if the rest of the protocols you use are not secured, using SSH you create a tunnel that is secured, you establish a secure communication, and then you can simply use it. Okay, and here is actually how a pipe looks like. Okay, so you have let's say a pipe between a child and parent process, right? So they always have a pipe between them to communicate, and then let's say the parent can write information on one end, and then the child can receive it. Okay, and the other way around. So that's it. I want to keep it brief, so you just know that those ways of communications exist, because the topic for today is mainly going to be, as I said, practical. So now, everybody should turn on their lab computers, okay, or if you have laptop, but I advise you to use the lab computer so we can do our practical exercise today. For those of you that came late, today we're going to do a Python program that will actually two Python programs, one producer program and one consumer program, and the producer is going to write into a shared memory, and then the consumer is going to consume the shared memory or read the information. Okay, this will happen live, so we will be able consistently to add messages to the shared memory from the producer and then read them from the consumer. Okay, so turn on your computers and also turn on PyCharm, so you have PyCharm installed everywhere and you should be able to use it, and I also do that as well. It is the same. So you're using sockets. Pipe is something that is you can imagine it on the top of the socket, right? So let's say this is why I said the SSH protocol, right? So let's say I want to establish a live connection between two devices, my device and your device, right? So I'm going to send an SSH request to you, so I will have the port number of the SSH protocol and your IP address. Okay, I will send you this and you will be okay. You received my request and you're like, okay, let's establish SSH connection. We're gonna exchange a few more SSH messages, because you'll ask me, okay, what is your authentication, what are your credentials? Then I will provide you also messages, and we're going to exchange this information. Once we exchange a few messages, some of them for authentication, some of them are going to be just me to ensure that the capabilities of your hardware can support the capabilities of my hardware so we can communicate. Once we do that, then we're gonna agree on that, and we're going to establish a connection, okay, on certain port numbers, which we're also going to provide this information while we communicate. Okay, normally how it's done, we're going to establish a connection on one port number, and we're going to use another one to exchange data. Okay, normally this is using the TCP protocol. And this is how we imagine this as a pipe, because we always have the connection between us. And once this part with the authentication and the connection is established, then we don't need to check anything else, and we can just shoot data here and there. When we're just sending messages, right, without establishing a pipe, we do request, you give me a response. I do another request, so maybe I'll close the port that I opened for the first request, and I'll open a new one. So pretty much this is the difference. Okay, any other questions before moving to the code? Okay. All right, so let's open PyCharm, and once you open it, you can create a new project. Okay, right here. Yours might look a little bit different. Yes. Okay, yeah, so you can just click create. I think, let me see. I think you entered not the computer science version. Because, let me see. So let's sign out. You know, there's one window where you can choose computer science or something else. Try to log in again, you'll see it. Yeah, it's computer science student, something like this.
Computer science, that's what I have to select.
Just computer science. Okay. Yeah, right here. Okay.
And you just open this one to copy the information.
Okay. Good. So yeah, you can now create a new project. So I will do exactly the same as you actually. Let me do this place. By the name, from those of you that came late, can you tell me which numbers you are so I can put you here in the list? Did I put you in the list?
Yeah, that is me.
This one is you?
Yes.
Moses, okay. Anyone else that I missed?
Number
10? Here?
Number 9. Yeah, but
10, and who is 9?
me.
Okay, yeah. Number 9. All right. Thank you, guys. All right. So I will just put the lights a little bit down so you can see better. Should we just keep it like this? Or it's too dark? I mean, you're doing everything on your monitor, so I think it's better. Okay. So now here, once you open PyCharm, you can start creating actually anything you want in Python. Okay, so usually by default you have this main file created. I'm just going to delete it. So you do a right click, delete. We're not gonna use that. Okay. And now the first thing that we're going to do is create a new Python file. Okay. And we're going to call that consumer. Consumer. And let's click enter. And then I will create another Python file called producer. Okay. So those are going to be the two applications that we will run in our system. Okay. Now, firstly, let's go here to the producer. Actually, the good thing of this project is that you will not need to install any libraries, nothing like this, because all the libraries we're going to use, all the Python libraries, are standard Python libraries, right? So we'll just need to write the code and that's it. Okay, so first of all, a popular library to create processes and shared memory is called multiprocessing. So in Python, those of you that are not familiar, to import something, you need to do from multiprocessing, okay, import shared memory. This means that from the library multiprocessing, I'm importing the function that is called shared memory. Okay, actually I'm importing this file, so the whole module. So everything inside this file shared memory that is predefined in every Python distribution, now I can use it. Okay. Anyone having any issues so far? Okay. Are we all having the producer and the consumer files? Is there anyone that doesn't have them yet to raise the hand? Okay, so I move on. Now, obviously here, since I'm seeing this in gray, this means that I imported the library, but it's not used yet. Okay, so now let's use it. The easiest way to implement something in Python is to create a function. Okay, so I'm gonna create a function, I'm gonna write the code, and after that I'm going to run this function. So in Python you can create a function by the def keyword. So I'm doing def. I'll call this function producer. Okay. And here I write all the code for the producer, which means I write the code for creating my memory. I write the code for writing into my memory. Okay. So once I do those two things in the function, then in the end of the file I will simply run the function, and that's it. So let's do it. Now, first step is to obviously create the shared memory. So let's call it SHM. We're gonna call our shared memory. This is just a name that we choose for it. It can be any name. It can be banana. It doesn't matter. Okay? So then I will use the shared memory that I imported. So I write SHM equals to shared memory. Okay. Dot. So this means that I'm accessing this file, shared memory. Okay. And when I do dot, I want to access something that's inside the file. So I will do shared memory. Okay. And if I go here into this file, you will see that shared memory is actually a class. Okay. So this is actually in every programming language, this is how it works. You always have files that are part of the programming language itself, and then you simply use those files when you build your code. Okay. So what I'm doing right now is I'm creating a new shared memory object. Obviously, shared memory is a class. So I'll create an instance of that class, and then this instance will have different functions, variables that I can use. This is the same as if I write here human equals, no, if I write Martin equals shared memory dot human. So I use the human class, so I will create a human that is called Martin that will have the attributes hands, legs, head, and also it will have functions run, swim, and so on. It is exactly the same thing. It's just here we're using the shared memory class and we're doing an instance of that class. Okay, so when you create a shared memory, sometimes you want to add some attributes. For example, when you create Martin, you want some custom things like I want him to be with black hair, tall, whatever, height, and something like this, right? So we're going to do the same with our shared memory. So what is important when you create a shared memory? Obviously the size is important, right? You want to say what the size is. Also, you want to name it, so it's important the name of the shared memory, right? So let's do that. So I will do, first of all, I write create equal to true, which is just the variable that says, okay, I want to create a shared memory. Then I'll write size. Okay, so you can see we have this variable called size. And I will specify that the size is 4096 bytes. Okay, so the size is in bytes. Okay, also in PyCharm, if you hover over this element, you can see some information about it, right? So the size is in integers. So obviously if here I write high, I know that this is not going to work because we're expecting an integer. Just like if you create a human and for height you add red, obviously it's not gonna work. And finally I'll create a name, okay, and this name can be OS, for example. Alright. Now the next thing that I'm going to do is I will just print a message. Okay, so some informational message for the users that run the producer. And I write here producer ready to write messages, and I also write type exit to quit. Okay, just some information for the users to know what to do once we run the producer. Now the next question I have for you guys is, since we already created our shared memory, now if I want to continuously be able to write into the memory, what should I do? So if I want to do encoding something continuous that is happening all the time and never stops, what function or what loop should I use? While? Yeah, exactly. So obviously if you want continuously to be able to write into the memory, we need to create a while loop and put everything inside this while loop. Okay? Also, we're gonna add something like, if the user types exit, we want to exit the while loop, so we stop asking the users to add something into the memory. And also when we press exit, we also want to delete or remove the shared memory, right? Let's do that. Now I will do here firstly try. Okay, and under it I will do finally. Okay, I will tell you what this means. So do you know what finally and try means? Anybody can tell me? Any ideas?
Some sort of exception.
When action is performed,
So exception there?
it checks whether the exception is handled or not. If that is not handled, exception
Yeah.
is not to the account.
Yeah, both of you are correct, exactly. So you can do try. This finally, obviously, is not an exception, but yes, you can also add try except, right? Just like how you said. So what we'll do here is I will do try and I will create a while loop. So I will try the code here, and once the code finishes or we exit the while loop, we exit the try block, we can do two things. So if the code finishes with error, we can write except, and if the code finishes with an error, we will say what we want to print to the user when there is an error in the code. Okay? So finally means that once everything in try finishes, okay, we're going to do some last lines of code just before exiting our try block. We need that because, as I said, once we go out of our while loop, we want to delete the shared memory, right? So we're gonna run the try block, we're gonna run the while loop inside, and once we exit the while loop, in the finally block, we're gonna write a few lines to delete the shared memory once we use it, okay? And for this reason, here, for now, of course, we're not going to use except, although it is a good practice to use except in case there are some errors that appear time to time and you want to handle them. Okay, but let's do that. So I will do try, and here I'm going to create a while loop. So I will do while true. While true means that we're going to loop constantly until we see the break keyword. Okay, no matter what, we're just going to loop over and over again. So when I create a while loop, I'll actually add pass here so I don't get error. Now, when you create a while loop, inside I'll create a new variable called message. Okay, and this will be equal to input, and I'll write enter message. Okay. Also, very quickly, I will add the exit condition. So I will do if message dot lower equals exit break. Okay. By the way, if you struggle to see very good from the screen, I also uploaded those files in Blackboard, so you can also download them from there and just see it like closely on your computer. Okay, just so you know. Okay, so who can tell me what happens in these lines right here? Okay, yeah, yeah, and you to add something? Yeah.
Function you can say like
In this line with the if, you mean?
The enter message is in the
Okay,
lowercase than
good. Yes, yes, true. Good. Anything else to add? Yeah.
It if the exit or
Yeah, yeah, exactly. So yeah, all of you are right. Obviously, you understand code, so this is pretty straightforward. Here we take message, so the input keyword, we just take message from the user. So we're gonna ask enter a message. The user will say good morning, and then message will be equal to good morning. Okay. And then here, if the user types here exit and click enter, then here we're gonna check, we're gonna convert it to lowercase. So even if he adds it with capital letters, we're still going to convert it in lowercase, and this will get triggered if we write exit, and we're gonna break the loop. Okay? Pretty straightforward so far. Okay, so now the next thing that we want to do, yes,
What's the reason to change it to lower?
sorry?
What's the reason to change it to lowercase?
It's just so it's more, let's say, comfortable for the user. Let's say if you write exit with capital E, right? Then you're not gonna trigger the if loop, because the if loop is going to check for lowercase. Okay. Let's say if here, yeah, it exactly. It is case sensitive, so it matters if I write capital letters or lowercase letters, right? In the message when I'm asked. So when I convert, so wherever the user writes, I'm gonna convert it to lowercase.
For the if function.
Yes, yes, exactly.
If function understand
Yeah,
it says exit.
yeah, exactly. It's just because it is case sensitive, and also that way we're way more safe. If the user types exit in a wrong way, let's say with caps and lowercase, then it's still going to be triggered. Okay. All right. So the next thing that we want to do now is obviously to save our message into the shared memory. Now, memory understands bytes. It doesn't understand words. Do we agree on that? Okay, so we need some way to convert our message that is with words and characters. We need to convert that in bytes. So let's do that. This is called encoding. Okay, so when you hear that something is encoded, this means you convert it into bytes. So let's do that. Let's do message bytes. Okay, this will be equal to message dot encode, and then you add the encoding protocol that you want to use. So I'm gonna use UTF-8. Okay, so message is a string. The string, every string can be encoded. Bless you. Okay, and this is the method we're going to use to encode the message. Okay, so now here we have it in bytes. Okay, so now we have just the bytes of the message, and the next thing that we want to do is to obviously save it into our memory. Now, here I just want to be safe, so I'm going to write if the length of the message bytes is higher than the shm.size. So I'm saying if the bytes of the message are more than the bytes of the shared memory, okay, I will cut the message, okay, because obviously I don't have enough space in my memory to save this message, right? So if this happens, what I want to do is, firstly I want to inform the user, so I will say print message too long, okay, and then I will do message bytes equal to message bytes shm dot size. Okay, so let's see what's happening here. I'll give you some time to write, and then I'll explain you exactly what's happening.
Number of bytes.
Exactly, yeah, exactly. This is exactly what we're doing. So yeah, what we're doing here is we're checking if the message bytes are higher than what we can accept in our memory. So obviously higher than 4098 bytes, I think it's our capacity. Sorry?
Yeah.
Okay. So if it is higher than the size of our shared memory, what we want to do is we want to cut the message. So when I do this here, it's telling take the message bytes from the beginning of the message until 4096, okay, until the size of the our memory, okay. So then this means that I will update the message bytes with the slice of the message bytes from the beginning up to the size of the memory. That way we can ensure that we're not going to crash and our code is not going to crash if the message is too big. Okay? Okay. So the next thing we're going to do is we're actually going to write the message into the shared memory. Okay? So I'm going to do shm dot buff. So a buffer is called the size of a memory. Okay, when I say I want to write into the buffer, this means that I'm writing into the space that the shared memory represents. So our buffer here is 4096 bytes. So I'll do shm.buff and actually make sure that you put it out of this if, okay, so it's triggered every time. So I will do shm.buff, and here I write into the buffer from the beginning until the length of the message in bytes. Okay, and this will be equal to message bytes. Okay, so that way I ensure I'm writing into the part of the buffer that is from the beginning of the buffer until the size of the message. Let's say until, so if the message says hi, let's say if each character is 1 byte, this means that we're going to write from the beginning until the second byte. Okay, and from the beginning until the second byte, let's say for example, is going to be equal to our message but in bytes. Okay, okay, so what I want to do next is to fill the bytes after that with zeros. That way I can identify where the end of our message is. So I can do that shm dot buff, okay, and we're gonna do len So we're gonna write now from the length of the message in bytes until the end, okay? And I'm just going to fill this with zeros. So to represent zeros in bytes, you can do B. So this is how you can actually write bytes live, okay? And then you can write a slash x 0, 0, okay? And I'll multiply this. I'll multiply it by the shm dot size minus the length of our message. So here pretty much I'm saying fill everything else other than the message. So from the length of the message until the end, okay? So we have the message hi, right? Okay. Then after the point that the message hi finishes, okay, this is where we want to start writing only zeros, okay? So we fill the buffer only with zeros, okay? So we identify that the rest of the buffer is empty, okay? And we do that by multiplying the 0 bytes by the size of the whole buffer, okay, minus the message bytes that are here. So then we're just gonna get the rest part. So we're gonna get the amount of zeros we need, and we're gonna assign them just to the empty space into our buffer, okay? That way we identify that the rest is empty, okay? Okay, and pretty much that's it. Now, what I want to say is just that the message has been written, so I will do print producer written. Then you can do that, so you can use those curly brackets in order to put a custom variable in a string. So I will do message, okay, to shared memory, okay. So obviously here we're using the original message, not the message bytes, because we want to print this message to the user, okay. And then you can use this. So in every string in Python, you can write the f keyword the f character in front, and once you do that, this means you can add variables from your code. If I remove the f, this will be taken just as it is, right? It will be the curly brackets will be taken. Also, the message will be just printed as message. It will be just printed as message, but not the actual value. Okay. All right. So now the final part is cleaning the memory. Okay. I'll give you some time to write if you need it. All right. And finally, let's do the finally block, right? So we want to clear up the memory once we're done. So here in the finally block, I will do print. Okay. Producer. Cleaning up shared memory. Okay. Alright, so I'm gonna clean that, and I will close it by doing shm dot close and then shm dot unlink. So you can see that if I do control and then click on close, I will see that close is a function within our shared memory class, right? This is how we get access to it. All right, so we're almost done. I'm just gonna add the main method so we're able to run this program from everywhere. So I would just do if name equals main, then run the producer function. Okay. So instead of having this in a function, I could just take all of this code, right? And I can just put it right here inside the main function. I could just do that. Okay, but when we have functions, see how more organized it is. You know that this function that is called producer is doing exactly this task, and also you can run the code multiple times without repetitions, without the need to repeat the code multiple times. Alright, so the next thing that we're going to do, I'm not going to run this now, because this is a program that needs to be constantly running. So let's first create the consumer, and after that we're going to execute both and see how they communicate. Alright, so for the consumer, let's go right here, and I will import the same libraries. So I will do from multiprocessing, import shared memory, and also I will import time. So time is another library with which you can add delays or anything related to time in your code. I add time because I want my code to sleep, for example, for 1 second in between receiving the messages, but you will see that later. Okay, now let's get started. So I'll create here the function called consumer. Okay, and then I will also create a try block. I'll create except block because here I will add some exceptions, and I also create a finally block. Okay, so in the try block, obviously here the first thing we want to try is to connect to the memory that's supposed to be already created. Now, this is some operation that is very vulnerable to errors, because obviously if the memory is not created, we will definitely break the try block. So for that reason, here we're going to add some exceptions. Okay, so I will add except, I will add the type of the error that I accept. Okay, and then I will add how I'm going to handle this error, what I want to do if this error appears. So for example, if we don't have the shared memory but we try to write into it, I want to print to the user, hey, you don't have the shared memory, so make sure that you set it up. Okay, but this later. Now let's write the code for accessing the memory. So I will do here again shm equals to shared memory, okay, dot shared memory, and here, since I don't want to create but I want to access it, note that in the previous code we use this variable create equal to true, right? So here we're not gonna do that. I will just specify the name of the shared memory that I want to connect to, which is called OS, right? So then I want to print in the same way some custom message to the user. So I write here consumer ready to read messages, and then I will write here press Ctrl plus C to stop. Okay, so let me go a little bit further so you can see. This is how it looks. Okay, and also if it happens that I access shared memory with messages that I already have shown, just in this case, I mean, you don't necessarily need to do it, but I'll do it. You can create a previous message variable. I'll write it, so previous message equals to empty string. And to this empty string, I can add every message that I received, so I make sure if I receive it again, I don't print it, okay? Sometimes you want to show the messages that you received again, so you will not need that. But it is just another mechanism that you can use. Alright, so once we're done with that, the next thing is we want to get all the messages that came from the producer, okay, and we want to get them continuously. So again, we will need to create a while loop. So let's do while true, okay, and the first thing I will do is I will create a buffer, okay, so I will create some variable that has exactly the same number of bytes like our shared memory. Okay, so I will do buffer equals to bytes and then shm, so the shared memory dot buff. Okay, so I'm gonna get the bytes from the shared memory buffer. So what that means? This means that wherever it was in the shared memory, we're going to take it and assign it to buffer. So we're going to do a copy of the shared memory buffer. And obviously the message that we want to get and receive and print is going to be there. It's going to be in those bytes, right? So now we did a copy of the buffer. And now what we want to do is to decode those bytes so we can get the actual message, how it looks, right? Let's do it. So I'll do now message equals buffer dot split. Okay, so I'm going to write here bits that are zeros, decode. So I'm just doing a few things at the same time here, but I will explain what this is. UTF-8. Okay, so what we're doing here is we are decoding the bytes of the message until we hit the first 0 byte. Okay, so once we hit the first 0 byte, we stop. And then so right here, this one will be only the bytes of the message that we want. Okay, so we're going to remove all the zeros and we're going to get just the first bytes that have our message. So until here we have bytes, only the bytes of the message. Now here I do dot decode. So here I'm decoding the bytes using exactly the same technique that I used to encode them. Okay? Yes?
What if encoded message has a 0?
So the encoded message has 0. So this is why we're writing 2 0 bytes. Okay? So let's say the message is going to be represented by a combination of zeros and ones, but let's say if you want to represent a character with 8 bytes, right, they're not going to be at any position to sequentially 0 bytes. That's why we use this in the end of the message. Okay, so when we see, okay, we reach 2 0 bytes, then let's say that this is the end of the message, and we're going to just take the rest of the message. Yeah, this is the idea. Okay, so now here we have the decoded message, and the next thing we want to do is simply to print it to the user. So obviously here I want to avoid repetitions, so I will do if message, so and message not equal to previous message. Okay. Then I want to print it. So I will do something like consumer, read from shared memory, and then I will show the message that I read. Okay. And then I will do previous message equals to message. Okay. So what I'm doing here is I'm saying if the message exists, so the message is not none. So if the message exists and the message is not equal to the previous message that we received, then print it and make the previous message equal to the current one. Okay. So next time, if I receive exactly the same message, I'm not gonna print it. Alright, and I'm just gonna add a short sleep here. So I will do time.sleep 1 second, which means that every second we're going to check for new messages created by the producer. Okay, so here's what happens. Now, we start the consumer, we assess the shared memory, right? And after that, we start monitoring constantly every second the shared memory. So we take the buffer of the shared memory, we decode the message, and we print it if there is anything. Oh, here's a message. Okay. And we do that every second. Okay. So now, we're done with the main part of the code. The last thing we need to do is to handle the exceptions. So if I find an exception that is called file not found error, so if I get this type of error, I want to print consumer shared memory not found. Make sure the producer is running, right? This is what we want to show to the users. You can also add another exception, right? So I'm just going to add except again. And here I will write, for example, keyboard interrupt. Okay. And I will print customer consumer exiting. Okay, just make sure that this is under this exception. I'll do this like that. Yes. Okay, so keyboard interrupt happens when you click Control C. So when you click Control C, instead of your program returning an error, you're going to see this message, consumer exiting. Okay, so your code is not gonna crash. I'm going to remove this pass keyword. I just left it so I don't get errors. And that's it, right? So you'll be able to exit. Now here, in the finally block, I'm just going to close the shared memory. So I'll do shm.close. Now, why I see this warning here? This is because the shared memory was referenced before assignment, right? So it could happen that the try block breaks even before this statement. Bless you. So what happens is the try block can break before this statement right here. Okay, so if it breaks before that, the SHM will never be created. So then here, how we can close something that has never been created, right? So if you want, for example, to remove this error, you can actually move this outside the try block, and you'll see that this will get removed, just because now we create the SHM before that. But both ways are going to work, since we can see visually that before the SHM is being created, nothing happens. Actually, in this case, we link it, we don't create it, we just access the shared memory.
Right after.
That's okay, both ways will work. You can keep it there.
Okay.
That's fine. Even in the original code that I created, it is after the try block, okay? I just noticed now that this is why we get the warning. But both ways are for sure going to work. Now, you're risking if, let's say, you put in the try block, and then before that you have some other code, right? So print something, do something, right? So if the code before this is created fails, obviously you're never gonna reach this line. But since this is the first line, it's not such a big issue, right? I will even leave it here just like you guys, so we can be on the same stage. All right. So now finally, what we want to do is simply to again write the main statement right here in order to execute the program. I'm just gonna copy it from the producer. I'll copy it right here, and I write consumer. Okay. All right. So how you can run it? Now let me see. I will show you how it runs from here. Okay. So we can have it on the video, and then I will show you for your specific case on the university computers how you can run it. Is in the same way. It's just the Windows terminal and the Mac terminals are slightly different. Okay, so now here you can run it. Okay, so just like every Python code, you can go in the console. And actually I'm gonna open two console windows, right? One for the producer and one for the consumer. So I will go to the directory and I will do Python producer.py. Actually I have Python 3. Okay, and now the producer is on. Okay, now you can write messages to the shared memory. Here I'm going to do Python 3 consumer.py. Okay, and now the consumer is waiting for messages. So let's see if it's gonna work, and then I will show you how you can do it on your computers. So let's say if I write hi, okay, you can see that our consumer received a message from the shared memory. If I write hi again, obviously you can see we don't receive it because the message got repeated. If I say my name is Martin, okay, you can see that the message got to our consumer. So now the consumer continuously gets the shared memory. All right, let's go to the lab pieces and I will show you how you can run it there. Good job, all of you completed the project, which is great. Have you completed it? You're smiling on the back. Yeah,